we have 2 chapters left, okay? One of them deals with area, the other one deals with surface area and volume. Okay, we take our EOI in here on the 29th, okay, of April. So we have just about a month to get everything crammed in and maybe about a week of review, okay? And I think through going through these 2 chapters, we will do some review over some of the stuff that we have covered, so, because it uses a lot of that. And I don't really think these chapters are horribly hard. They deal with formulas. If you can follow a formula, then you should be able to do it. The hard part's going to come in for those of you that didn't learn your 30, 60, 90, 45, 45, 90 stuff, the trig stuff, Pythagorean theorem, how to leave things exact. Those are the things that give people fits, okay? So, with that said, we are going to start on the area of parallelograms and triangles. Area is the number of square units in the interior of a figure. So if you're going to lay carpet or if you're going to tile something, okay, that is area. How many square units, whether it be square inches, square feet, square miles, whatever. How is that different from perimeter? Well, perimeter is like crown molding or your baseboards in your house, okay? That goes all the way around. Area is in square units. Perimeter is in linear units, okay? The formula for the area of a parallelogram is base times height. Your base and your height have to be perpendicular to each other. Now, here are 3 different types of parallelograms, okay? Your base and your height, like I said, have to be perpendicular to each other. This is actually a square, but you use the same formula, base times height. Some of you may be more familiar with this formula, and it works as well, side squared for a square, okay? This is a rectangle. A lot of people learn length times width, but your length and your width are actually your base and your height, yes? Because they're perpendicular to each other. So you really can memorize one formula for all of them, okay? Base times height. Just remember that the base and the height have to be perpendicular to each other. And like I said before, when you give your answer for area, it's always in square units. Okay, so we're going to find the area and the perimeter of these 3 figures, okay? Again, now when you show your work, I expect you to write the formula down, show me what numbers you're plugging in, and give me the answer. Okay, I will not accept just answers. Everybody hear me? Okay, write the formula down, show me the numbers you're plugging in, and give me the answers. Why do I make you do this? It's not because I'm mean. It's because if I want to give partial credit, okay, I can't unless I know that you know what you're plugging in there. Okay, there's no way for me to check your calculator. So if you write it down, then you may just make an error in your head if you're doing it mentally or in the calculator. At least I know that you had the right idea when you were doing it. Okay, so what kind of figure is this first one? It's a square. But I didn't give you the base or the height. I gave you the diagonal. What does the diagonal create 2 of? Okay, isosceles right triangles, but more specifically, the 45, 45, 90-degree triangles, okay? And we learned that in a 45, 45, 90-degree triangle, your hypotenuse is radical 2 times the leg, okay? So, if my hypotenuse is 16, what is my leg going to be? How am I going to figure that out? Okay, you're going to divide by radical 2, and then you have to rationalize the denominator. So you end up with 16 radical 2 over 2, which is 8 radical 2. In a 45, 45, 90, anytime they give you the hypotenuse, the leg is always half of that times radical 2. Okay? So half of 16 is 8 radical 2. Okay? So that's something that you can remember here. Okay. So, to find the area, I'm going to do 8 radical 2 times 8 radical 2. 8 times 8 is 64. Radical 2 times radical 2 is 2. And so you end up with 128 meters squared. Okay, perimeter, it is a square. All 4 sides are the same, so I'm going to do 4 times the length of the side. The length of the side is 8 radical 2. So what's my perimeter going to be? 32 radical 2. Okay, if I plug that into my calculator, I end up with 45.3 meters. Remember, perimeter is in linear meters. Okay. Now, as far as leaving things exact, on your test, I may ask for it exact. I may ask for it rounded to the nearest 10th or 100th. You need to be prepared to give me both. You need to leave your answer exact until the very last possible second, okay? And then plug it in. If you start plugging all this different stuff in here and there, okay, and you get rounded answers, it takes your answer further and further away from the truth, and you have no idea where you got this decimal from. If you leave it exact, it's a lot easier to tell where the answer came from, okay? And I can help you figure out what you did wrong if you make a mistake. All right. Okay, so here's another one. We're going to find the area again, okay? I need a base and a height. What do I have? I have a base, but I don't have a height, right? Okay. I also have a 30, 60, 90 degree triangle, don't I? Okay. And in the 30, 60, 90 degree triangle, you're given the hypotenuse. If you know the hypotenuse, you can find the short, right? So if the hypotenuse is 2 times the short, and the hypotenuse is 12, then the short's going to be 6. So this down here is going to be 6, but I need the long, don't I? Okay. And say again? It's the short times radical 3. So if my short is 6, then my long is going to be 6 radical 3. Okay. So now my base is 18, and my height is 6 radical 3. So that gives me an area of 108 radical 3. And the approximation to that would be 187.1 inches squared. And again, you need to be prepared to give me both answers. Okay, now perimeter in a rectangle, or the parallelogram, is a parallelogram. 2 times the length plus 2 times the width. What is my length and width? 12 and 18. So it's 2 times 12 plus 2 times 18. Doesn't really matter which one's the length and which one's the width in this case. So we end up with 24 plus 36, which is 60 inches. Any questions at all on that one? Okay. All right, now here's another parallelogram. Area. Do I have my base and my height? Yes, what are my base and my height?
23.
23 and 24. This is the actual base right here, okay? I had to extend it to drop the height. Sometimes they drop the height inside the parallelogram, but you don't include that portion as part of the base if it goes outside, okay? So my base and my height are 23 and 24. So 23 times 24 is 552 feet squared. That was easy, huh? Wish they were all that easy, yeah? Okay. Perimeter is 2 times the length plus 2 times the width. Now I have one of them, right, which is 23, but I don't have the other. What am I going to have to do? I'm going to have to do the Pythagorean theorem. So I'm going to have to do 24 squared plus 7 squared equals c squared. Is this a triple? You might know?
Yeah,
It is one. 7, 24, 25. If I added this together, I'd end up with 625 equals c squared, which is 25. So this right here ends up being 25. Okay, so we've got 2 times 23 plus 2 times 25. And 2 times 23 is 46. 2 times 25 is 50. And you end up with 96 feet. Any questions on that? Are we good so far? Not really hard. Just got to go back and remember some things, yeah? Okay, now the next thing we want to look at is the area addition postulate. And it says that the area of a region is the sum of the areas of its non-overlapping parts, okay? Now, what that refers to is if you have an oddly shaped figure like that, okay? And I want to find the area of it. What this tells us is if I break this into pieces that I can actually find the area of, then I can add those two areas together for the whole area, okay? So, like, I could do this, call this area 1, call this area 2, and the area of the total, I use these little subscripts to indicate what I'm talking about because sometimes there's more than one. The area of the total would be area 1 plus area 2. Something else that you could do is instead of breaking it into pieces, you could make one big piece, okay? And like make one big rectangle, okay? And so to find the area of the total in that case, you would take the area of the whole thing and subtract, we'll call this area 3, and subtract area 3 from it. You can do that too. So you can make one big shape and then subtract the parts you don't want. Okay, that works also. All right, and then the next postulate says that if two figures are congruent, then they have the same area. So if I have a pair of congruent triangles, then their areas are going to be the same. Okay, two congruent triangles, then the areas are going to be the same. All right, any questions before we go on? Okay, now, the next one we want to talk about is the area of a triangle. Okay, and the formula for the area of a triangle is either half base times height or base times height divided by 2. They mean the same thing, yes? Most of you probably are familiar with base times height divided by 2. Is that the one you use more? Okay, I'm more familiar with the other, so if I do the other, that's just because it's out of habit. But one thing I want to show you before we get through this, let's say that I had a base of 8 and a height of 12. Okay? Now, doing it your way, you would have done 8 times 12 divided by 2. Not all of us know 8 times 12 in our head. Some of us do. But you end up with 96 divided by 2, which is 48, right? But something that you can do, a little shortcut that you can do, is to take half of one or half of the other. But you never take half of both. Okay? So I might be able to do this more easily in my head if I took half of 8, which is 4 times 12, which is 48. Or I could do half of 12, which is 6, and do 8 times 6, which is 48. So you can take half of one, half of the other, or half of the product. But you don't take half of both unless they're added together. Okay? When they're multiplied together, it's half of one, half of the other, or half of both. Okay? The product of both. Okay? Product of both. All right, so just keep that in mind. You may just choose to do it like this, but you'll see how sometimes it's a little bit easier, especially if you're having to give an exact answer, to do it the other way. Not as calculator reliant, maybe. Okay, so we want to find the perimeter and the area of each triangle. Okay, so remember that area is base times height divided by 2. Do I have my base and my height?
Yes.
Yes. What are they?
27
and 30. So 27 and 30 times 30 divided by 2. Now, it's probably not to my benefit so much here to do, so I could just multiply them together and take half, and I'm going to end up with 405 inches squared. So there's my area. Okay? Now, what about my perimeter? Do I have everything I need for it?
No.
I have 2 of them. I have 27 and I have 41, but I don't have that third side.
Exactly.
Okay, so I could do the Pythagorean theorem with this little right triangle to the right, and I could do 19 squared plus 30 squared equals c squared. 19 squared, I think, is 361. Yeah. Plus 30 squared is 900 equals c squared. This ends up being 1261 equals c squared. I do not think that that will simplify. Okay. So I've got plus 1261. Now, if they ask for an exact answer, I could add the constants together, but I couldn't add that. I just have to make it a separate term. I would end up with 68 plus radical 1261. Okay? But if they wanted an answer rounded to the nearest tenth, you could plug that into your calculator, and you would get 103.5 inches. There is something, I believe, on your EOI, and I was showing my other class this, where you had like 2 radical 2 plus 6 plus 3 radical 6 plus 9. If you want to know the perimeter, they might give you something like that. Okay? You could add the constants together, which is 15, but you couldn't add these together, and so you would have to leave your answer like that. Okay? They have to be the exact same radical in order to add them together. Now, if this happened to be 3 radical 2, then you could, and it would be 15 plus 5 radical 2. Okay? All right? But in order to add the radicals together, they have to be the exact same. It's like apples and oranges. You have to add apples together and oranges together, or you can't have an apple orange. Okay? All right. Questions on that? All right, here we go. What kind of triangle is this?
36. Well, equilateral.
It's an equilateral. It is isosceles as well. It's equilateral, but it's got two 30, 60, 90 degree triangles in it. Okay, so each one of these are 26, right? When I drop that height, what do these both become? 13. Okay, so I can now look at this little guy here, and I need my height in order to find the area. Okay? Well, I know my hypotenuse. I know my short. What's my long going to be?
Radical 3 times.
13 radical 3. Okay, so my height is 13 radical 3. So my area, which is base times height divided by 2, my base is 26, my height is 13 radical 3, and divide by 2. Now, here is where I would take half of the 26. What is half of 26? 13, and 13 times 13 radical 3 is going to be 169 radical 3. See, that was easy to do in my head, and I didn't have to rely on my calculator. Okay? So that would be my exact answer. That would be centimeters squared. But if they wanted the answer rounded to the nearest tenth, I would plug that in, and I'd get 292.7 centimeters squared. Does everybody see what I did there? Okay. All right, so that takes care of my area. Now my perimeter, it is equilateral, right? So all three sides are the same. So 3 times 26 is going to give me 78, 12, 18, 78 centimeters. All right. Here's another example. DeAndre needs enough mulch to cover the triangular garden shown and enough paving stones to border it. If one bag of mulch covers 12 square feet and one paving stone provides 4-inch border, how many bags of mulch and how many stones does he need to buy? Okay, so the mulch covers 12 square feet, all right? So what are we going to have to find in order to figure out how much mulch we need? The area, okay? So we're going to look at the mulch, and we know the area, it's a triangle, is base times height divided by 2. What are my base and my height? 9 and 7, so 7 times 9 divided by 2 gives me an area of 31.5 square feet, right? Okay, so one bag of mulch covers 12 square feet. So what am I going to do? Okay, divide by 12, and it's like 2 point something. 2.625. So how many bags of mulch will I need?
3.
3 bags of mulch. Okay, now I need to work on the stones. See how many stones that I need to buy. Okay, so it says, so in order to figure out how many stones, what do we need to find? The perimeter, okay. And I think we had everything, right? So it's 23 plus 15 plus 7. So I end up with a perimeter of 45 feet. So what am I going to have to do in order to figure out how many stones I need to buy?
Change your feet.
Okay, I've got to change my feet to inches because the paving stones are in inches, right? How many of you didn't think about that? Be careful, okay? All right, so we got to multiply 45 times 12. And so my new perimeter, 540, is 540 inches. And then what would I do to figure out how many stones that I need? Divide by 4, because there's 4 inches on a stone. And that tells me 135 stones. So I need 3 bags of mulch and 135 stones. Now, how many of you would just go to the store and buy some stones and take them home and see if that was enough and then go buy more? Okay, that's probably what I would do. But would this save you time, maybe, and some money? It very well might, because if you're like me, I am terrible about returning stuff. I just end up keeping it. Okay? If I had done this, like especially the stones, and I went and bought 150 stones, okay? Well, I probably wouldn't have taken the other ones back. Number one, my kids probably would have broke them, or I would have broke them, or whatever, okay? So it might have saved you a little bit of time and money to get your measuring tape out and do it real quick, and that would have given you a better idea of how much that you need.
But
Yes?
then you have to measure all the stones at the store.
Well, but they're all basically measured the same. I mean, we're talking about paving stones that were uniformly,
Not just like rocks.
not like rocks like you'd find out, in the backyard.
At least one of them.
Well, yeah, you would have to measure at least one of them. So usually that information they'll have, like, So this is definitely something you could use, and yeah.
Within a day. So it wouldn't even matter.
But I tell you what, some of this stuff you will use if you ever build a house or if you ever remodel a home. Okay, this stuff will be applicable, I promise. Especially if you want to do it and save money. Okay.
I ended up killing them on accident.
Huh?
I'd end up killing the plants in less than a day.
Oh, well, you never know. I had never had much of a green thumb, and I'm get better as I get older. Oh, yeah. Okay. Here's another one. Last one. The height of a triangle is 5 centimeters more than its base. The area of the triangle is 52 square centimeters. Find the base and the height. Okay, so they're giving me the height of this triangle in terms of the base. So what am I going to let the base be? X. Okay, and so then my height's going to be what? X plus 5. And it tells me that my area is 52 inches squared. It's terrible. Centimeters. Okay, thank you. 52 centimeters squared. Okay, so we know that area is base times height divided by 2. My area is 52. My base is x. My height is x plus 5 divided by 2. What should I do first? Foil?
No, destruction.
Okay, I'm going to distribute. What else am I going to do? Do I want to get rid of this fraction, or do I want to work with a fraction? Okay, so I could probably do both of those at the same time. Multiply both sides by 2, which gives me 104, and then distribute, okay? Okay, so we end up with this lovely problem that has an x squared and an x. Okay, so what do?
Just subtract one.
Okay, before we can do anything, we got to get it
Equal to 0.
equal to 0. So I'm going to bring the 104 over. Now, when you do this, some of you made this mistake on the test before last. You always want your x squared to be positive, and you want it to be in descending order, okay? Now, we're not going to FOIL, we're going to undo FOIL, okay? It's a difference, okay? All right, but it does involve the word, okay? All right, so I need two numbers that multiply together to give me 104 and add together to give me 5. Now we're going to work our way there. Some of you may know the answer, but that's okay, because some of us still have trouble coming up with this answer. Okay? So I want to look at what my possibilities are. Okay? I could do 2 and 52, but that gives me a difference of 50. Okay? And these are going to be opposites. Since this is negative, these are going to be opposite signs. 4 goes into this. Okay? 4 goes into here 26 times. That gives me a difference of 22, so that won't work. So what about 8? Well, 8 divide into 104, okay? 8 goes into 104 13 times, and that gives me a difference of 5, right? Okay, so I found what I need to know. So I've got a 13 and an 8. They're going to be opposite signs. Which one needs to be positive?
The
bigger one, because it's the sum is 5, positive 5. Okay, so once I have it factored, I set the factors equal to 0. Should be a line just right there. And x is negative 13 and a positive 8. Can I use both of those answers? No, this guy's out because he's negative, okay? So this tells me that my base is 8 centimeters, and then my height is 5 more than that, which is going to be 13 centimeters. Okay? The more you do these, the easier to get, especially when it doesn't have a number in front of the x squared. When it has a number in front of the x squared, it gets a little trickier. But okay, now before I end, I want to show you one more thing. Okay, this is just real quick. this right here is a square yard. It's 1 yard by 1 yard. So that's 1 yard squared. How many square feet is that? 9. Okay? Because it's 3 feet by 3 feet, which is 9 feet squared. Okay? How many square inches is that?
36 times what?
Okay, how many inches are in a yard?
36.
36.
1296.
So 36 by 36 is 1296. Okay, good. All right, one more. This right here is a square foot. It's 1 foot by 1 foot. So this is 1 square foot. How many square inches is that? 144. So 12 inches by 12 inches, which would be 144 inches squared. And I promise you, at some point in time in your life, you will use it. I promise. Okay? When we built our house, we went and did all this kind of stuff, and we were trying to figure cost. And you might measure in feet, but you got to change to inches. But it's not linear inches; it's square inches, and that kind of thing. So keep that in mind. Okay?
Good thing you're a math teacher.
Yeah, but I don't really think I thought about the fact that a square inch or a square foot was 144 square inches. I don't think I ever really thought about that because when I went to do it, I was like, oh, yeah. I don't really think that all that came, it wasn't really in the forefront of my mind. And I see now, and I use it a lot more now than I did. And not because I teach geometry, just we've done a lot of little projects, So. All right, your assignment is on the board.